Researchers predict that given the recent rise in carbon dioxide emissions over a relatively short time scale, a sixth extinction will depend on whether a critical amount of carbon is added to the oceans. Representational image Reuters increasing carbon levels in the oceans may lead to the sixth mass extinction in Earth's history by about 2100, MIT scientists have predicted, after analyzing data from the last 540 million years. Researchers from Massachusetts Institute of Technology (MIT) in the U.S. analyzed significant changes in the carbon cycle over the last 540 million years, including the 5 mass extinction events. They identified thresholds of catastrophe in the carbon cycle that, if exceeded, would lead to an unstable environment and ultimately, mass extinction. The last such event, known as the Cretaceous Tertiary extinction, occurred about 66 million years ago. It wiped out some 3/4 of the plant and animal species on Earth. Researchers propose that mass extinction occurs if one of 2 thresholds are crossed. First, the changes in the carbon cycle that occur over long time scales, extinctions will follow, if those changes occur at rates faster than global ecosystems can adapt, they said. Second, carbon perturbations that take place over shorter time scales, the pace of carbon cycle changes will not matter. Instead, the size or magnitude of the change will determine the likelihood of an extinction event, they said. Researchers predict that given the recent rise in carbon dioxide emissions over a relatively short time scale, a sixth extinction will depend on whether a critical amount of carbon is added to the oceans. Daniel Rothman, professor at MIT, derived a simple mathematical formula based on basic physical principles that relates the critical rate and magnitude of change in the carbon cycle to the timescale that separates fast from slow change. He hypothesized that this formula should predict whether mass extinction, or some other sort of global catastrophe, would occur. Rothman identified 31 events in the last 542 million years in which a significant change occurred in Earth's carbon cycle. For each event, including the 5 previous mass extinctions, Rothman noted the change in carbon, expressed in the geochemical record as a change in the relative abundance of 2 isotopes, carbon-12 and carbon-13. He also noted the duration of time over which the changes occurred. He then devised a mathematical transformation to convert these quantities into the total mass of carbon that was added to the oceans during each event. Finally, he plotted both the mass and time scale of each event. That amount, calculated, is about 310 gigatons, which the researchers estimate to be roughly equivalent to the amount of carbon that human activities will have added to the world's oceans by the year 2100. It would take about 10,000 years for such ecological disasters to play out. However, by 2100 the world may have tipped into unknown territory, said Rothman. This is not saying that disaster occurs the next day. It is saying that, if left unchecked, the carbon cycle would move into a realm which would be no longer stable and would behave in a way that would be difficult to predict, Rothman added. In the geologic past, this type of behavior is associated with mass extinction, he added. The study was published in the journal Science Advances.